Hey everyone, welcome to 1.5 infinite limits. This is what happens when you're looking at a limit and you say, well, it's going to infinity or negative infinity. What happens then, Mr. Barman? And I say, let me tell you about that today. But before we get started and answer that question, let me ask you a question about trivia. And here is the question. How many stranded strangers start on each Survivor series? The answer, later on. Okay. So what we're going to do is we're going to talk about a definition for AB Calc. There's other definitions that deal with other stuff that we don't need to know right now. So what we're going to do is we're going to look at f of x equals 3x minus 2. 3 divided by x minus 2. So what we're going to do is we are going to look at this graph. And here's the graph right here. Okay, so you say, as it comes from the left side, it's going down, and then as it comes from the right side, it's going up. So is there a limit? Well, they're not approaching each other. Or actually, I guess it looks like this. So they're not approaching each other, so that means the limit's probably not going to exist, and that's a big part of infinite limits, is that infinite limits don't exist, even though it looks like they could when written in certain ways. Okay, so what we're going to do is we are going to look at the graph. Oops, that's here. There we go. We're going to look at the graph here. There's, oh, easy. We're going to look at the graph, and then if we look at the table, the same thing. Oh, we can't really see it that well, but it goes to 2 is the error, and everywhere else it seems to be okay. So it looks like 2 is the error. So that is going to be where the limit does no longer exist, kind of where it breaks apart. And it looks like if you look at the graph right here, 2 seems to be kind of the place where there is going to be what's called an asymptote. Okay, so here's our definition. A limit in which f of x increases or decreases without bound as x approaches c. Now when they say without bound, really that means it's going towards infinity or negative infinity. So when they say increases or decreases without bound, it's not going to slow down and just keeps on going up towards infinity. Alright, so here's a quick note that you should know. If you say the limit as f of x, the limit of f of x equals infinity, does not mean the limit exists. Instead, it actually means the limit fails to exist. So it looks like it could because you say, oh, it equals something. Well, be careful about this equal sign. You got to say, what does it equal? If it equals infinity, we say the limit does not exist. If you say it just equals a number, then the limit exists. But because it equals infinity, no. So here's our example. Use this function to determine the limit as x approaches 2 from the left and the right. So we're going to go back to this here. I'm going to see if I can maybe make those a little bit bigger. There we go. That's a little bit better. And so if I move in here, if we go from the left into the right, I have 1, 2, 3. Okay. So what we're going to do is let's see if we can just go back and change our window here for the table. And we're going to start at right there. Okay. So now let's... Give me 1 second. Alright. And that's a little bit better. So you can see as we approach from the left side, it's going towards negative 300. And as you're approaching from the right side, it's going to positive 300. So it starts at 60. So you can kind of assume based on what we know about the graph and what we know from this table point, we're going up by 0.01, that it's getting really, really negative and really, really positive. So we can say that it's going towards negative and positive infinity. Alright, so remember just how we write that is the limit as x approaches 2 from the negative side of, let's just do 3 over x minus 2, is going to equal negative infinity, and the limit as x approaches 2 from the positive side of 3 over x minus 2 is going to equal positive infinity. Alright, so we know that they're going away from each other. We know that 2 is going to be that vertical asymptote. One's going towards negative, one's going towards positive. You say, but Mr. Barman, what if they're both going towards infinity? Then what? And I say, well, as long as they're going towards infinity on both sides, then it's going to be an infinite limit. It doesn't matter if they're going away from each other or if they're going towards each other. Alright, so let's keep going. Definition of a vertical asymptote. If f of x approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equals c is a vertical asymptote of the graph of x. So it doesn't matter positive or negative, or they're both going negative, they're both going positive, or any other combination of positive or negative infinity is going to be a vertical asymptote. Alright, so remember we had talked about holes or removable and non-removables? Well, here's something you kind of help you out with whether it's going to be an asymptote or a hole. Asymptotes you can't factor and cancel. wholes, you can factor and cancel. So for example, this one right here is going to be an asymptote because you can't factor anything out from the numerator denominator. This one's going to be a whole because I can factor out the x minus 2 from top and bottom. Alright, so that will be a whole at 2. This will be an asymptote at 2. So when you look at the divide by 0, that's going to be the case. Alright, so that's how you can tell those two. This next definition is kind of annoying because it's a lot of words, but it's way easier when you look at a real example. But let's just go through this because it's always fun to get some good examples. Vertical asymptotes. Let f and g be continuous functions on an open interval containing c. If f of c does not equal 0 and g of c does equal 0, and there exists an open interval containing c such that g of x does not equal 0 for all x not equal to c in the interval, then the graph of the function given by h of x equals f of x over g of x has an asymptote at x equals c. Alright, what does that all mean? First of all, it says this part right here, before that, there's going to be, c is going to be somewhere on our interval. Alright, somewhere in between, which we can choose anyway, so that's not really a big deal. And this next part says that we don't want the top and bottom to equal 0, because then we have an indeterminate limit. We don't want 0 divided by 0, so as long as we have it not 0 divided by 0 at some point, that's what we want. So this has to be like 5 over 0, 10 over 0, whatever over 0. Okay, and there exists an open interval containing c such that g of x does not equal 0 for all x not c. That means basically g of x cannot equal 0 is what they're trying to say. Because if it equals 0 for everything, then we have a problem. We only want it to equal 0 at c, at one point. Alright? And then we can say it has a vertical asymptote at that one point as long as g of x does not equal 0, because then we have a big problem. Why would you ever want to divide anything by 0 anyway? That doesn't seem like a very good function. So let's do an example to maybe clear this up just a little bit, or at least to give you some context for what we're talking about. Determine all vertical asymptotes of the graph of each function. First of all, is my top number ever going to be 0? Don't have to worry about that. No. I want to know when is the denominator going to equal 0. So when does 2 parentheses x plus 1 equal 0? And that's when x equals negative 1. Right? If I plug in negative 1 plus 1 is 0 times 2 is still going to be 0. That's really all we're doing is trying to figure out when is the denominator going to be 0. That's a nice easy one. No problem. This next one, I have x squared plus 1 over x squared minus 1 equals f of x. I want to know when is my denominator equal to 0. So x squared minus 1, I can actually factor that because that's a difference of two squares. X minus 1 and x plus 1. Right? If I FOIL, the two middle terms cancel out, and I'll be left with x squared minus 1. So that means I can get two answers. I can say x equals positive 1, x equals negative 1. Alright, so those are my two possible asymptotes. What I want to do is check the numerator to see if either one of those is 0, because remember the top number cannot equal 0. That f of x on the top can't equal 0. So if I plug in this to x squared plus 1 for both of them, so I do 1 squared plus 1 is 2, negative 1 squared plus 1 is also 2. So, either way, it works out. They're both zeros in the denominator and not in the numerator. So my asymptotes are at x equals 1. My asymptotes for part B are x equals 2. I'm sorry, not x equals 2, because I got my answers here. Those are my asymptotes. Alright, there we go. X equals 1 and x equals negative 1. It's got two asymptotes, which is fine. You can have more than one. And lastly, we have f of x equals cotangent of x. So what I did was I just put on my graphing calculator here. You can see cotangent, remember, is cosine over sine. I put that in. And then I graphed it. And you can see, there we go, that I have a lot of vertical asymptotes. I do. There can be more than one. There can be a lot, especially with repeating cotangent tangent functions. They're just going to repeat. All right. So it looks like it's going to be at 0. And then it's going to be at pi, because this is 0, pi, 2 pi. So I did that. Okay, so it's going to be at 0. And after looking at the graph, we know this. We could also look at it and say, okay, we have 0. Right here is an error. So we know that that is going to be an asymptote. So what I'm going to do is I'm going to say I have asymptotes at x equals 0, pi, 2 pi, and so on. But instead of writing them all, remember what we do? X equals pi times n. Or you could write it as x equals n times pi. Alright, So either one of those would be okay. So finding infinite limits, not too bad, especially if you have a graphing calculator. You can graph it, look at where they were to diverge or go together towards infinity, and then also just look at the denominators. What's going to happen in the denominators, and then just make sure you double check back in the numerator to make sure you don't have a 0 divide by 0, and then you might have to reevaluate it, maybe see if you can cancel some stuff out, stuff like that. Alright, so here is your assignment. We're going to do this exploration right here. It says, use graphing utility to graph each function. For each function, analytically find the single real number c that is not in the domain, aka the asymptote. Then graphically find the limit of f of x as x approaches c from the left and from the right. So are they going towards each other? Do they look like this? Do they look like this? Do they look like this? So are they going same way positive, opposite ways, or same way negative towards negative infinity? Alright, there it is, and don't forget your trivia question, which again was, how many stranded strangers start each Survivor series? And the correct answer, 16. Good luck!